like, share, subscribe.
Hey y'all, welcome back. In this video, I'm going to review the concepts that you will need to be familiar with to be successful on the TSIA2 math test. This test used to be called the TSI test, but has recently been updated and has been given a new name, the TSIA2. First, let's talk about what you can expect to see on the recently updated test. The TSI math test is a 20-question test, and if you get enough of those questions right, you're done. Congratulations, you passed the test. However, if you don't pass the first set of 20 questions, you'll be directed to a 48-question diagnostic math test that will help pinpoint the areas that you're struggling with the most. Now, schools can use this diagnostic section to help put you in the right class, but if you get to that diagnostic section, do not give up. This is really important. If you get enough of those questions right in that 48 diagnostic section, you can still pass the test. This is one of the major differences between the original TSI and the TSIA2 math test. So do your best on those first 20 questions. That's your best shot of passing the test. However, if you do end up getting taken to that diagnostic section, don't give up. Do your best because you could still have an opportunity to pass the test. Now, if you want an idea of what kinds of questions you can expect to see on this test, the College Board has released a practice test, and if you click this link right above here, it'll take you to a playlist where I work out every problem on that practice test. So, without further ado, let's jump into this video. So let's go ahead and jump into some of these practice problems. I've got 40 here for you, and that's a little bit longer than what the actual test will be, but I think these questions do a good job of covering all the bases here. So we'll go through these, and hopefully by the end of this video you'll have a better idea of what to expect on the TSIA2 test. All right, so let's begin. Number 1 says if 3t minus 7 equals 5t, then what does 6t equal? So here we can approach this two ways. We can either try to isolate 6t, but I think it's actually easier to just find t and then we'll multiply it by 6 to figure out what 6t is. So the equation here is 3t minus 7 equals 5t. First, I will subtract 3t from both sides. So doing that, 5t minus 3t is going to be 2t. And then if I divide both sides by t, I get negative 7 halves as t. Negative 7 halves as a decimal is going to be negative 3.5. And then if I want to get my final answer here, 6t is going to be 3t, I'm sorry, it's going to be t. 6t will be negative 3.5 times 6. Which equals 21. So our answer is Number 2 says if variables x and y are proportional, directly proportional, and y equals 2 when x equals 3, what is the value of y when x equals 9? So to be directly proportional, that means there is a constant that we can multiply by x to get y. Okay, there's no y-intercept essentially. So to figure out what this constant is, set x to be 3 and y to be 2. And so to figure out this constant, we'll divide both sides by 3, and so k will be 2/3. So the equation we'll use here is y equals 2/3 times x, and so if we want to find the value of y when x is 9, we'll multiply 2/3 times 9. And that equals 6. So our answer is B. Number 3 says find the equation of a line passing through 6, 9 and 0, 0. So first we'll find the slope. The change in y is going to be minus 9. To get from 9 to 0, we subtract 9. And our change of x from 6 to 0 is going to be minus 6. So the change in y is -9, the change in x is -6, so our slope will be -9 over -6. We can clearly reduce this. A negative divided by a negative is a positive, so we can get rid of those negatives. And then if we divide both the numerator and the denominator by 3, we're going to get 3/2. So our slope is 3/2. That pretty much gives us our answer here because there's only one equation that has a slope of 3/2. But if you wanted to actually come up with the equation using point-slope form, you would do y minus y1. And I think I'll use this second point as my x1, y1 because they're both 0, and so it'll make the equation a little bit easier to write. Actually, we don't even need that. However, we can see that 0, 0 is a point on the line. This is the y-intercept, so our y-intercept is just guaranteed to be 0 anyway. So that's number 3. Number 4 says there are 3x minus 2 trees planted in each row of a rectangular parcel of land. If there are a total of 24x minus 16 trees planted in the parcel, how many rows of trees are there in the parcel? So we've got a rectangle essentially here, and each row has 3x minus 2 trees. So I'll just say it's going to be our length here. Let me make the rectangle a little smaller. It says there are a total of 24x minus 16 trees. So that's going to be kind of like our area here. It says how many rows are in the parcel. So essentially what we need to do is figure out what do I need to multiply 3x minus 2 by to get 24x minus 16. And for both terms, you can see that we could just multiply an 8. So that's going to be the number of rows. And our answer is D. Number 5 says a group of 18 people ordered soup and sandwiches for lunch. Each person in the group had either one soup or one sandwich. The sandwiches cost $7.75 each, and the soups cost $4.50 each. If the total cost of all 18 lunches was $113.50, how many sandwiches were ordered? So there are going to be two equations that we can set up here. The two variables that we want to use are going to be the number of sandwiches and the number of soups. And we know that at least the number of sandwiches has to be a variable because that's what it's asking for. So I'll just say, since they both start with S, I'll just use X and Y. So I'll let X be the number of sandwiches. And I'll let Y be the number of soups. So since each person either had one soup or one sandwich, we know that the total number of sandwiches plus the total number of soups is 18. If the sandwiches cost $7.75, we can multiply that by how many sandwiches were ordered, plus $4.50 for the number of soups that were ordered, and the total amount was $113.50. So we can solve this as a system of equations, but I think it might be easier to just use our answer choices here to solve for to figure out which one is our answer. So let's start with 7. So it's saying, okay, if 7 was the number of sandwiches that were ordered, then we could plug in 7 right here, right, to figure out how many soups there would be. So 18 minus 7 would be 11. 7 plus 11 is 18. And basically what I want to check here is to see if 7 and 11 work in this second equation. If they do, then I've got my answer. If they don't, I'll go back and try the next one. So $7.75 times 7 plus $4.50 times $7.75 times 7 plus $4.50 times 11, that equals $103.75. So that's not what we're looking for. We want it to be 113. So we know the answer is not A. So let's try a couple of different numbers here. We'll let x be 8 for this second guess. Switch the color here. And so if x is 8, then y would need to be 10 in order for them to add up to 18. I'm going to put 8 here. I'm going to put 10 here. I'm going to type this in. Let's see if that works. $7.75 times 8 plus $4.50 times 10. And that one equals $107. So it's not going to be B. Is it going to be D? Are we going to have to go through all four of these? Sometimes that happens. Sometimes you get lucky and it's the first answer choice. So I wouldn't give up on this strategy. Next, I'll make x 9, and that would make y also 9. I'm going to plug these two numbers in for x and y. 775 times 9 plus 450 times 9 is $110.25. So unfortunately, C doesn't work either. And we'll try D. I'm assuming it's going to work. If it doesn't, that means we made a mistake somewhere. So, we're still going to test this out. If x is 10, that means y has to be 8. So 775 times 10 plus 450 times 8 does in fact give me the $113.50. So my answer is D. Number 6, which of the following equations has both 1 and -3 as solutions? So what I would do here is work backwards. There's two ways you could approach this. You could just plug in a 1 and -3 into x and see which one works. That's definitely a good strategy if you're not really sure algebraically how to answer this. So you just plug in 1 into x, make sure that one works, but you also have to check -3. But this one is not so hard to solve, so I'm going to just solve it directly here. If 1 is a solution, then that means x minus 1 must be one of the factors. And if x equals -3 is a solution, then that means x plus 3 must be a factor as well. And so if I multiply these two factors together, I should get my answer. So x times x is x squared. Just using the distributive property here. X times x, and then I'll do x times 3, which will be 3x. Followed by -1 times x, which is -1x. And then finally, -1 times 3 is -3. So combining my two like terms, which are these two linear terms right here, get x squared plus 2x minus 3, and so we can see that our answer is B. Number 7. In the xy plane, what is the y-intercept of the graph of this equation? So the y-intercept is going to be the value of the function when x is 0. Just make a little point here, x must be 0. So all you have to do here is substitute 0 into this equation. Y equals 2 times 0 plus 3 times 0 minus 4. 0 plus 3 is 0. Is 3, and 0 minus 4 is -4. So we're just going to multiply 2 times 3, which is 6, times -4 is -24. So our answer is A. Number 8 says x to the 4th minus 1. And this is a difference of two squares. So the difference of two squares factoring technique says that if you've got a squared minus b squared, we can factor this as a plus b times a minus b. All right, this is called the difference of two squares. And so we have this kind of setup here for number 8, where a is x squared. So I'll just put x squared here. X squared squared and b is just 1. 1 squared is 1. So this is going to factor as x squared plus 1 times x squared minus 1. You might notice that none of the answer choices are this exactly, but that's because we actually have another instance of the difference of two squares over here with the x squared minus 1. You can factor that a little bit further and write this as x plus 1 times x minus 1. So looking at our answer choices, we can see that the correct answer is A. Now, if you forget how to do the difference of two squares factoring, one thing that you could do to answer this question is just to pick any value you want for x, so like pick 7 or something like that, and then type 7 in for x for the original equation, and go through your answer choices, plugging in 7 for x, and find out which one equals the same thing. You can definitely get this one right using that strategy. You can use a similar strategy for number 9. Just pick different values for x and y, plug them in, and see what the expression equals. And then you can plug those same numbers in for x and y for the answer choices and see which one is the same thing. And you can get the right answer that way. But I'll show you how to work this one out using our properties of exponents. So the first thing we need to do is apply that cubic exponent that's on the outside of the parentheses to every factor that is on the inside of the parentheses, including the 3, which is what most people will forget. So 3 cubed is 3 times 3 times 3, which is 27. Then when you raise each of these other factors to the third power, since they already have an exponent on them, you need to multiply the powers. Raising a power to a power, or to raise a power to a power, you've got to multiply the power. So 2 times 3 would be 6, so this would be x to the 6th, and 3 times 3 would be 9, so this would be y to the 9th. We get 27, x to the 6th, y to the 9th, and our answer is D. Number 10 says if the square root of 5 minus x equals 4, then what does x equal? Well, the first thing we want to do here is to isolate x, square both sides. But before we go any further here, any problem that's just a solve for x problem like this, where you're just trying to figure out what x is, you want to take advantage of the fact that this test is multiple choice. So if, on any of these questions where you're solving for x, you really could just take the answer choices, plug them in, and see which one works. So just know that that is an option for you. But I'll go ahead and solve it sort of the proper way here so you can see how to do it. After you square both sides, you get 5 minus x equals 16. Then you could subtract 5 from both sides, leaving you with negative x equals 11. And then divide both sides by negative 1 to get x equals negative 11. Again, you could just plug in these answer choices and plug in negative 11 here. You'll see that it works. So don't forget about that strategy. Number 11 says if x minus 1 over x equals 20, then what does x equal? Again, this is another solve for x problem, so you really could just plug these answer choices into x and see what works. But I'll show you how to solve it otherwise. First thing I would do here is multiply x on both sides of the equation so that I get rid of that fraction. X minus 1 then would equal 20x. Then I can subtract x on both sides to get negative 1 equals 19x. Then if I divide both sides by 19, I'm going to get x equals negative 1 over 19, and our answer is C. Number 12 says a ball was kicked into the air from a balcony 20 feet above the ground, and the ball's height above the ground in feet t seconds after the ball was kicked is given by the equation y of t equals negative 16t squared plus 32t plus 20. What was the maximum height in feet of the ball above the ground after it was kicked? So just to give you a little visual of what's happening here, ball starts at 20 feet, goes up, and then comes back down. What we're looking for is this point right here. Now, this point is called the vertex. Okay, I'm going to call it h comma k. And to find the maximum height of the ball, really what we need to do is find this k value. So we need to find the maximum. To find that maximum, we need to find the vertex. So to find the h of the vertex, we can compute negative b over 2a using the coefficients of the equation that was given. So b over here is 32, and a is negative 16. We can simplify this as 32 divided by negative 32. I don't know, negative 32 over negative 32. So this is just going to equal 1. So that means that the maximum occurs at 1 second. So at that point, you want to plug in 1 into the function to find out what the maximum height is. So the k is going to be negative 16 times 1 squared, which is just 1, plus 32 times 1, plus 20. This is something that you could probably get away without using a calculator, but hopefully you have at least a 4-function calculator for this one. Negative 16 plus 32 plus 20 is 36. So our answer is C. Number 13 says the yard behind Cindy's house is rectangular in shape and has a perimeter of 72 feet. So 2 times the length plus 2 times the width is 72. If the length of the yard is 18 feet longer than the width of the yard, what is the area of the yard in square feet? So the area here is going to be length times width, and so we're going to need to find both the length and the width. So unfortunately, because of the way this problem's set up, I don't think it's really going to be reasonable to kind of work backwards from the answer choices here. So we're going to solve this using a technique called substitution. Since the length is 18 more than the width, we can replace the L in the second equation, or I guess the first, since we wrote it first, with that 18 plus W. So I get 2 times 18 plus W plus 2W equals 72. To solve this, I need to distribute the 2. 2 times 18 is 36. So 36 plus 2W plus another 2W is 72. 2W plus 2W is 4W. Now I can subtract 36 from both sides to get 4W equals 36. And then dividing both sides by 4 is going to result in the width being 9 feet. Now once we figure out what the width is, it should be pretty easy to calculate the length, because the length is 18 feet more than the width. So 18 plus 9 is going to be 27. So the length is 27. Now we can calculate the area, which is length times width. So the area will be 27 times 9, which is 243. And that would be in square feet. So our answer here is C. Let's move on to number 14. This says, the table above shows the high temperature last Thursday for 5 cities, A through E. If the median of this Thursday high temperature for these cities was 81 degrees Fahrenheit, which of the following could not have been the high temperature last Thursday for city A? So what I'll do first is write these values in order. So the smallest or the lowest temperature here is 62. Then we've got 81 and 87, and finally 93. We've got one more temperature here. We don't know what it is though. It's T. So it says that the median of the high temperature was 81 degrees. So for that to be the median, it needs to be the number that's in the middle of the list. And so in order for 81 to be in the middle, so you've got 2 numbers to the right of that, we also need 2 numbers to the left of it. So that means that this temperature, T degrees Fahrenheit, needs to come like not necessarily before the 62, but definitely before the 81, so that we could have two values that are less than 81. So really any number less than 81 is going to do it for us. And this says, just to add one more little complexity here, it says which of the following could not have been the high temperature. So 3 out of these 4 are going to be less than 81. Okay, so you can see 75 is less than 81, so that's not going to be our answer. 65 and 55 are all less than 81. So our correct answer here will be A. Number 15 says there are 20 children in the cast of a class play, and 8 of the children are boys. Of the boys, 4 have a speaking part in the play, and of the girls, 8 do not have a speaking part of the play. If a child from the cast of the play is chosen at random, what is the probability that the child has a speaking part? So the way that we calculate probability not sure what's going on with the the text there, but the probability is going to be a fraction. It's going to be the number of desired outcomes divided by the total number of outcomes. And just to make this look a little nicer, I'm going to throw in a little space here. Nope. Here's what I'll do. Put a little space like this. Okay, so we've got the desired outcomes divided by the total number of outcomes. So the desired outcomes here are going to be that a child has a speaking part. So what we need to do is figure out how many total children there are and how many of them have a speaking part. So if we look back at here, it says there's 20 children. It doesn't really matter if they're boys or girls. The total number of children is 20. So it's going to be something over 20. The number of desired outcomes here are the kids that have a speaking part. So it says 4 have a speaking part. That's going to be the boys, but then you have to figure out, okay, well, how many girls have a speaking part? It says of the girls, 8 do not have a speaking part. So if there are 8 boys, then that means there are 12 girls. If 8 do not have a speaking part in the play, that means 4 of those 12 do. So 4 plus 4 is a total of 8, and so our probability is going to be 8 over 20, which will reduce, if we divide both of those by 4, to 2/5. So the correct answer is A. Number 16, the variables x and y are directly proportional. So that means that we can write an equation, y equals mx with no b. For a directly proportional equation, there's no y-intercept, or I guess to be more accurate, the y-intercept is 0. So we know there's some constant, which is the rate of change times x. Okay, and again, I'm starting this equation just from the fact that it said it was directly proportional. It also says that y equals 4 when x equals 9. Using that information, we can figure out what our slope or our rate of change is. When y is 4, x is 9. So if I divide both sides by 9 here, I get my slope, which is 4/9. So then the follow-up question here is, what is the value of y when x is 18? So if I have my equation, y equals mx, and I already figured out what my m was, right? I figured out that my slope was 4/9. So when x is 18, we want to know the value of y. Y is going to be 4/9 times 18. You could put this in your calculator most likely, but 18 divided by 9 is 2, and 2 times 4 is 8. So we get our answer. When x is 18, y is 8. Number 17 says, evaluate the expression when x is 2, y is -3, and z is -1. So we've got this expression, and all we need to do really is just plug in 2, -3, and -1 into x, y, and z into the expression. So we've got 2 times 2 plus 3 times -3 minus -1. Just type it in kind of exactly like that, and then put it in your calculator. That's what I'm doing now. 2 times 2 plus 3 times -3 minus -1. And so I'm getting -4 here. Number 18 asks us to factor this difference of two squares. The format for doing this is if you've got something like a squared minus b squared. So just like I said, exactly a difference between two squares, we can factor that out as a plus b times a minus b. So if we've got something like number 18, which is 25x squared minus 36, we can write that as 5x plus 6 times 5x minus 6. That's basically our answer. Oops, that's a b, not a 6. So yeah, you just need to know how to actually do this. So to come up with these numbers, you just find the square root of each of these two terms. And so we can see our answer is D. Now, if you're worried about D because the factors are in a different order, multiplication is commutative, which means that the order doesn't matter. 2 times 3 is the same as 3 times 2. So it's okay that this one has the minus 1 first. That doesn't really make a difference. Number 19, we are solving an equation for x. So I'm just going to retype it over here so we can have all the work right underneath it. First thing I'm going to do is use the distributive property on this 7. So I'm going to multiply 7 times x and 7 times 1. To get 7x plus 7. Next, I'm going to start to combine like terms to simplify the left-hand side of my expression, my equation. 4x plus 7x is going to be 11x. And then negative 5 plus 7 is going to be positive 2. Next, I'm going to subtract this 6x on both sides, and 11x minus 6x is 5x. Now we've got a nice little two-step equation here, so I'm going to subtract 2 from both sides, and then divide both sides by 5, and I get 1. So my answer is 1. Number 20, looks like we've got a rational equation, so we need to find a common denominator here, and to do that, we're going to multiply each fraction by the other fraction's denominator. So I'm just going to rewrite number 20 here. We've got 3x plus 6 all over 3 minus 4x over x minus 3 equals x. So I'm going to multiply this first fraction by x minus 3 over x minus 3 so that I can get this denominator in there. So x minus 3 on the top and times x minus 3 on the bottom. For the second fraction, I'm going to multiply that by 3 over 3. So you can see if I multiply this bottom by 3, then I'll have the common denominator. So I'm going to multiply this by 3, and I'm going to multiply this by 3. Once you've got your common denominator, you can go ahead and subtract those fractions. And when you do that, the denominator will stay the same, and you'll just subtract the numerator. Multiplying these two together, we'll do that kind of in the same step. X times 3x is going to be it's going to be 3x squared. And then x times 6 is 6x. Negative 3 times 3x is going to be negative 9x. And then 6 times negative 3 is going to be negative 18. 6 minus 9 is going to be negative 3x. So this is the numerator of that first fraction. And then I'm going to subtract this numerator on the second fraction. 4 times 3 is 12, so just to simplify things, I'm going to write it as 12x. And then my denominator here, I'm just really not going to mess with it because there's a possibility that we're going to get x minus 3 as a factor, and then if I multiply it together, I won't necessarily catch that I can cancel that factor out. So now I'm going to combine like terms in the numerator and try to factor what I have. So 3x squared minus 3x minus 12x would be minus 15x minus 18. All that is over 3 times x minus 3. That equals x. Whew, this problem's got a little bit of a doozy here. Okay, so we do need to factor that numerator just to make sure that these x minus 3's don't get canceled out. And I guess we need to decide if this is even factorable to begin with. So since the first term is 3x squared, I know my first two terms are going to be 3x and x. Get that. I'm going to just kind of take a guess here. Usually doesn't take me too many guesses to get there, but two numbers that multiply to give me negative 18 would be 6 and 3, where one of those is negative. So I'm going to put the negative 6 here and then plus 3 here. And then to see if I did that right, 3x times 6 is negative 18x plus 30x does give me that negative 15. So actually that's correct. The other thing I see here is I do have a GCF that I can divide out of that first one, and it is a 3. So I'm going to take this whole equation here and just rewrite this as 3 times x plus 1. Okay, now you can see that these 3's are going to reduce. I was kind of hoping we could get that x minus 3 to reduce, but we can't, and that's okay. So next, I'm going to set these two things equal to each other. So I'm going to multiply both sides by x minus 3. And then I'm going to actually multiply all this out. So I'll FOIL the left-hand side, which will give me x squared minus, minus 6 plus 1 would be minus 5x, and then minus 6 equals x squared minus 3x. So if I subtract x squared on both sides, these will go away. And then if I add 5x to both sides, I'm going to end up with negative 6 equals 2x. And then finally, dividing both sides by 2 gives me x equals negative 3. Now you're seeing here, the algebra is pretty intense for this problem. And I think this is probably going to be a little bit beyond what you can expect to see on the test. I don't know that for a fact, but I have not really seen too many that were this complicated. Now that all being said, we've got all the work here shown to the right here. But one way that you could work out this number 20, which I would probably recommend over doing all this algebra, is just to use your answer choices and plug them into x. So like if I plug in negative 3 into x everywhere where I see x, and I evaluate that out, I should get negative 3. So or I should get a true statement, I should say, where the left-hand side equals the right-hand side. So as you go through your answer choices and plug these into the calculator, if you're going to use this technique of just working backwards from the answers, you'll find that negative 3 is the solution. Number 21 is also a solve for x kind of problem. And so I think just to kind of showcase that strategy here, I'll just do what I was talking about for number 20 and just plug in the answer choices and see which one works. So for this one, I'm going to start by trying to plug in 6. So this would be like 6 plus 3. We want to know, is that equal to 6 minus 3? So the square root of, 6 plus 3 is 9. 6 minus 3 is 3. Does the square root of 9 equal 3? Well, yeah, sure it does. Square root of 9 is 3. So that means that 6 is a solution, which means that it's either going to be A, B, or D, because C doesn't have 6 as a solution. So now we need to test. There could only be like one more answer here, and it's either going to be 1 or 13, or maybe if there's nothing, maybe there just is one solution. But we're going to test out both of those numbers. So first I'll test 13. I've got 13 plus 3 and 13 minus 3. So 13 plus 3 is the square root of 16. It's making me think this actually is not going to be an answer. And 13 minus 3 is 10. So the square root of 16 is 4. That does not equal 10. So this equality is not true. Just scratch out the equal sign on all these, and that means that 13 is not a solution. So the last thing to check here would be 1, just to verify or confirm that that either is or is not a solution. So we'll do this last one here. 1 plus 3 underneath the square root on the left side, and on the right side we've got 1 minus 3. So the left-hand side is the square root of 4, because 1 plus 3 is 4. And on the right side, we get 1 minus 3, which is negative 2. And the square root of 4 just equals positive 2. It does not equal negative 2. So that means that 1 is not a solution to this one either. So the correct answer then is A. For 22, solve the inequality. I think I'll go back and actually work this one out rather than just trying to plug in answers here, because it is a good idea to know how to do these. So first, I will add 3x to both sides. Well, I guess first maybe let's just retype the equation. So we got it ready to go. But yeah, I want to add 3x to both sides to get rid of it on this right-hand side. So negative 2x plus 3x is positive 1x. And then I want to add 1 to both sides. And 8 plus 1 is 9. Get x is greater than 9. Now, it doesn't really look like that in the answer choices. For some reason, they flipped it here. Not really sure why they did that, but the x is still the greater number in this statement, so it's still going to be true. Number 13, it asks us to solve this using the square root property, but you could just approach it like we did earlier and just test the answer choices into x. But I'll go ahead and just show you how you get the answer the proper way. First, I'm just going to retype the equation, and then we'll start solving it. So to solve this, I'm going to add 36 to both sides, move that 36 over, and then I'm going to take the square root of both sides. Now, the thing you got to remember is anytime you take the square root of both sides of an equation, you do have to put a little plus or minus over here on the other side of the equation. So that'd be plus or minus 6. And then finally, I'm going to subtract 9 from both sides. So I get x equals negative 9 plus or minus 6. We do get two answers here, one with the plus, one with the minus. If I use the plus and I get negative 9 plus 6, that's going to be negative 3. And if I use the minus, negative 5 minus 6 would be negative 15. So our answer is B. Number 24 wants us to solve using the zero factor property. And so we will go ahead and factor this. But 24, 25, these problems can also be solved by just plugging in the answer choices into x. So don't forget about that strategy. But yeah, so here we want to factor. So we've got 10x squared plus 23x plus 12 equals 0. So we want to try to factor this into a pair of binomials here. So I'll just kind of set up my binomials. And here I'm going to do a little guess and check here. I need that first term to be 10x squared. I'm just going to throw down 5x and 2x as my first two terms. 5 times 2 is 10. X times x is x squared. I might have to change these, but I don't know. It's just my gut feeling that those are going to be the first terms. For the last term, we've got 12, so we have to find two numbers that multiply to give me 12. I'll just, to kick this off, start with 3 and 4 as a guess. But really, how you're going to figure out what that correct combination is you're going to multiply the first and the last term, the inside terms. So the outside terms, the inside terms. The inside terms, 3 times 2x is 6x. For the outside terms, we got 20x. And what we actually want here is for these to add up to 23, which obviously that's not happening with this problem. So we've got the wrong combination. So we're going to have to try something else. How about instead of 3 and 4, we try 6 and 2 and see if that leads us anywhere. 6 times 2 is going to be 12. So this is 12x. Apply these together. 5 times 2 is 10. We get 10x. We're so close. We're trying to get these to add up to 23, but just not there yet. Okay, how about 4 and 3? I feel like maybe the 4 and 3 might work. Let's see. We try 4 and 3. We get 4 times 2 is 8x. 5 times 3 is 15. Actually, does this work? 15 and 8, yeah, that's 23. Okay, so here we go. So here's our two factors. Then once you factorize this out, we can use the zero product property, which says that if you have a product that equals 0, then at least one of the factors must be 0. So the way that applies here is since we've got a product of binomials that equals 0, at least one of those binomials does need to be 0. So we're either going to have 5x plus 4 equals 0 or 2x plus 3 equals 0. Then if I solve this left equation by subtracting 4 and then dividing by 5, I get x equals negative 4/5. And if I do the same thing for this other linear equation, I get x equals negative 3/2. Those are my two solutions. So I'm going to look for those in my answer choices. And it looks like I got them right here. Choice D. Number 25 says solve the equation using the quadratic formula. So the quadratic formula, in case you've forgotten, is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And the a, the b, and the c are all going to be coming from these coefficients. So the a is 4, the b is 8, and the c is... I'm just going to copy this over so I don't have to retype it and fill in my a, b, and c. So my b is 8, my 8 is 4, and then my c is 1. Now this is something that we can basically put in the calculator. It looks like we're going to have to do a little simplifying to get our solutions here, but let's go ahead and start that simplification process. So 2 times 4 is 8, do that. And then in this numerator, we've got 8 squared, which is 64, 8 squared minus 4 times 4 times 1. And so what that gives me is 48. Then you can see we're very close to being done here, but we do need to simplify this a little bit. So 48, let's see here, that would be a perfect square factor of that. 16, is it divisible by 16? I think it might be. Yeah, 16 times 3. Okay, so this is going to be 4 root 3 when we go to rewrite it. So right here, 48, root 48 reduces to 4 root 3. And then I can divide all this stuff by 2 to reduce my fraction. So this will be 4, this will be 2, and this will be 4. Oh, and actually, you know what? I could go one step further. I don't need to divide these by 2. Let's divide by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. 8 divided by 4 is 2. We have negative 2 plus or minus root 3 over 2. Our answer is C. Number 26 says the height of a box is 7 inches. So we've got this box. So it says the height of the box is 7 inches. The length is 6 more than the width. So if we'll say this is the width, then the length, and it doesn't really matter which ones, which here, but the length is going to be 6 more than the width. So 6 plus W. Then it says find the length, which is this 6 plus W. Find the length if the volume is 280. So we'll set up our little volume equation here, which is length times width times height. Fill in the values. So L here is 6 plus W. W is just going to leave that as W. And then the height is 7. So here I've got 7W times this. So I'm going to distribute that in. Apply. 7 times 6 is 42. So we get 42W plus 7W. Okay, so if the volume is 280 cubic inches, I'm going to set the volume equal to 280, and now we're going to solve for W. 42 plus 7 is going to be 49, so I've got 280 equals 49W. And then if we divide both sides by 49, wait a minute, something's not right here. Oh, I see. When I distributed this 7w in, I forgot to multiply the w here. So this should actually be 7w squared. So unfortunately, we're going to have to solve it a little bit differently. What I would do here at this point is probably do a little guess and check to make sure, I think versus doing like the quadratic formula. Now we did the quadratic formula in the last problem, so if you know how to do that, that's fine. But yeah, I think at this point, let's just plug some numbers in and see what works. So first we'll try 4. And so I've got 280 equals 42 times 4 plus 7 times 4 squared. And the question is really, does this actually equal 280? So I'm not going to put that yet. So 42 times 4 plus 7 times 4 squared is actually, it works out, 280. Look at that. So yeah, our answer here is going to be 4 inches. Number 27 says a ladder is resting against a wall. So here's your building. Here's a little ladder. That is not a ladder you can see. Here's a ladder. Okay, so it says the top of the ladder touches the wall at a height at 9 feet. So right here, here's 9 feet. Find the height of the ladder if the length is 3 more than the distance from the wall. So the length, call that L, that's what we're trying to find, is 3, or here, I'll type it out so it looks a little nicer. The length is 3 more than, we'll call this X, the distance from the wall. Find the length of the ladder. So this is what we're trying to find. Okay, so basically what we're going to do here is set up a little Pythagorean theorem. A squared plus B squared equals C squared. So before I start substituting things in for A, B, and C, I think what might make this problem a little easier is if instead of throwing in an extra variable here, X, we don't really need that variable. Instead of trying to write the length in terms of the distance from the building, here I've got 3 more than the length of the building. Let's put this distance from the building, let's write that in terms of L. And so what I mean by that is, like, if we just make this side L, then this distance down here would be 3 less than L. So instead of X, I'm going to write this as L minus 3. So now I can go in and substitute all these expressions in for A, B, and C. Just make sure that the hypotenuse here, the L, that's going to be our C here. So the setup here will be L minus 3 squared plus 9 squared equals L squared, where L is the length of the ladder. And so first I'll square out this binomial, which just means you multiply it by itself, and you'll get X squared, or L squared, minus 6L plus 9. And then 9 squared is 81, so plus 81 equals L squared. If I subtract L squared from both sides, I can get rid of both of those quadratic terms. And this will just be 0 on this side. Then I can combine my like terms here. 81 plus 9 is 90. Now I've got a nice little two-step equation here that shouldn't be too bad to solve. First I'll subtract 90 from both sides. And then I'll divide both sides by -6. And so you should get L equals, let's see here, 90 divided by 6 is 15. So our answer is D. Number 28 says if an object is propelled upward from a height of 144 feet at an initial velocity of 128 feet per second, then its height after t seconds is given by this equation. After how many seconds does the object hit the ground? So the object will hit the ground when the height is 0. So that's kind of our key piece of information here. Okay, so we want to know, when is the height 0? The height is 0 when it's on the ground. So what we need to do is we need to figure out what value can we plug in for t that will make it 0. So really we're trying to solve this equation. Negative 16t squared plus 128t plus 144 equals 0. Now I think we want to take advantage of the fact that this is a multiple choice question, and we could just plug in the values here for the number of seconds into t and see which one actually gives us a 0. We can also solve this using the quadratic formula, but I just think it's a lot easier to solve this by plugging in the answer choices. So that's what I'm going to do here. So first we'll try 9 seconds. And so I'll just replace t with 9. So negative 16 times 9 squared plus 128 times 9 plus 144. I want to know what that equals. Hopefully it equals 0. We could be done, but if it doesn't, we'll try the next option. So I'm going to go to my calculator, start typing this in. Negative 16 times 9 squared plus 128 times 9 plus 144. And I get, oh wow, I get 0. So yeah, there you go. Our answer is A. Always love it when it's that first answer choice. Number 29 says a rocket is propelled upward from the top of a building 210 feet tall at an initial velocity of 112 feet per second. The function that describes the height of the rocket in terms of t is given here. I'll go ahead and let's highlight this function. So this is giving the height, and we want to know, when does it reach the maximum height? So what we need to do here is figure out, which of these t values is going to maximize the height. So I think what we ought to do is just plug those numbers in and see which one gives us the biggest height. There is a roundabout way of finding that. Basically what you want to do is find the vertex. But again, this is a multiple choice test, so let's take advantage of that. So I'll just test each one of these and see which one gives me the biggest height. So negative 16 times 2.8 squared plus 112 times 2.8 plus 210. Let's see what that thing equals. Negative 16 times 2.8 squared plus 112 times 2.8 plus 210. And that gives me, forgot something on there. Much better. 398.16. So that is our number to beat. That is our height that we want to get. We want to know if this is the maximum height or not. So we'll do that again, but for 3.5. So let's see what we get there. I'm just going to replace these 2.8s with 3.5. Type that into your calculator, which is what I'm doing behind the scenes here. And on this one, I get 406. So now we got a new height to beat. Okay, 7 seconds. Now, one thing I'll say, if this is the answer, well, I'll wait till we get past that. Okay, so let's test 7 and see what that gives me. Here, I'll just replace all these 3.5s with 7. Negative 16 times 7 squared. Go. Okay, I got it all typed in. That gives me 210, so that is definitely not going to be right. Kind of thinking it's going to be 3.5. I just got a feeling about that one. Here's 5.6, so we got negative 16 times 5.6 squared. Got a lot of extra stuff here. Let's fix that up. plus 112 times 5.6 plus that last 210, and let's see what we get here. Just typing this in, with replacing the 7 with a 5.6, and I'm getting 335.44. So we can see that the time at which our height is maximum is going to be 3.5 seconds, because this number is the biggest. Number 30 says, if an object is propelled upward from a height of 48 feet at an initial velocity of 98 feet per second, then its height after t seconds is given. So we got kind of a similar setup here to the last couple problems. After how many seconds will the object reach a height of 192 feet? Once again, we're just going to test these out and see which one equals 192. So we'll start with 1.5. And yeah, we got negative 16 times 1.5 squared plus 96 times 1.5 plus 48. And I'm going to type all that in. We're looking for the one that equals 192 here, so we won't necessarily have to test all of them. We just need to test them until we get the answer. Now, if you want to be 100% confident that you got it right, it doesn't hurt to test the other ones. I'm getting 156 here, so I'm guessing it's going to be a little bit above 1.5. 3 seems like maybe that'll work. I don't know. Let's see. So we'll just throw in a 3 here instead of a 1.5. I'm going to type that into my calculator. I would assume on a problem like this that you would definitely get a calculator. And I get 192, which is going to be our answer. I had a feeling about that 3. So yeah, so this is it. This is our answer, and so our answer here is going to be B. B's in a row. Oh, I guess not. Number 31. Find the length of a rectangular lot with a perimeter of 82 and a length that's 5 meters more than the width. So if we got this rectangle, the perimeter is all the sides added together. So that would be like 2 lengths and 2 widths. Add up all those, we should get 82. It says the length, so I'll make this the length, is 5 more than the width. So 5 plus W, or I'll just write it as W plus 5. And here's the width. So what we want to do is find the length. So I'm going to replace, actually, if I'm trying to find the length, what I want to do is actually rewrite the width in terms of length. So if the length is 5 more than the width, then the width is 5 less than the length. So the length minus 5. Doing this will make it so that when I substitute these back into the perimeter equation, I don't have to like convert anything. So yeah, basically what we're going to do here is we're going to replace the W with L minus 5. I have 2L plus 2 times the width, which is 5 less than the length, equals 82. And now I just need to solve this equation. So distributing that 2 to the L minus 5 gives me 2L minus 10 equals 82. Combining these two like terms is going to give me 4L. So I get 4L minus 10 equals 82. I'm going to have to continue this work over here. Ran out of space. Adding 10 to both sides is going to give me 4L equals 92. And then if I divide 92 by 4, I get 23. L is 23. And let's go look at our answer choices here. We see that the answer is C. 32. Chuck and Dana agreed to meet in Chicago for the weekend. Chuck travels 174 miles in the same time. Dana travels 159 miles. If Chuck's rate of travel is 5 miles per hour more than Dana's, and they travel at the same length of time, at what speed does Chuck travel? So let's break this down. I'm not 100% sure where this is going to go, but one thing you might want to be aware of is that distance is equal to rate times time. And so we might, at least the way I'm going to approach this is going to use this little formula here. So I'm going to basically try to keep track of both Chuck and Dana. We'll see if we can't like put together an equation here. So Chuck is traveling 174 miles. So that's the distance. Dana, so I'll just say equals rate times time. Come back to that. Dana, on the other hand, it traveled 159 miles. So this would be 159 is her rate times time. If Chuck's rate of travel, so that's the rate, is 5 more than Dana's. So what are we trying to, we're trying to find Chuck's rate. So I'm going to leave that as a variable. And if he's traveling 5 miles per hour more than Dana, then that means Dana's rate of travel is 5 less than Chuck's. But now this R is the same. It also says they travel at the same length of time. So the T's are the same. We want to know what speed does Chuck travel. So if we're solving for the rate for Chuck, we would divide both sides by the time. So we'd have 174 equals, or 174 divided by T equals the rate. So if we can figure out what this time is, we can solve for this rate. Looking back over at Dana, what we want to do is try to rearrange this equation for time. So I'm going to divide both sides by r minus 5. So I have 159 divided by r minus 5, and that equals the time. So now I can replace this time with this expression, this 159 over r minus 5. That's what I'm going to do over here. 174 divided by this other fraction, 159 over r minus 5, equals his rate. Okay, so dividing by a fraction is the same as multiplying by its reciprocal. So I can rewrite this as 174 times r minus 5 over 159. Then I'm going to try to clean up this equation just a bit. So I'm going to distribute the 174 and divide everything by 159. I'm not actually going to do any of the arithmetic. I'm going to leave it as a fraction. But so that's going to leave me with 174r over 159 minus, here we've got to multiply 174 times 5, so that's 870. So minus 870 over 159 equals r. Now we've got a bunch of fractions here, and we can clear those fractions by simply multiplying both sides of the equation by 159. So that's going to be my next step here, is to multiply both sides of the equation by 159 in an effort to get rid of those fractions. So that'll leave me with 174r minus 870 equals 159r. From there, I'm going to subtract 174r from both sides, which will give me negative 15r on the right-hand side. Lastly, I'm going to divide that 870 by 15 to get our answer here for the rate, which is, oh, there we go, the rate, which is 58 miles per hour. Yeah, 32 is A. 33. A triangular shaped lake front has a perimeter of 1,800 feet. I'm going to draw a little triangle here. Don't know what the angles are or anything, but we know the perimeter. We'll just call this side A, B, and C. Don't know what they are, but those three side lengths should add up to 1,800. One side is 100 feet longer than the shortest side. I don't know which one's which here, so I'm just going to say that this side is the first side they're talking about, one side. So I'll call this one is 100 feet longer than the shortest side. So I'm going to call the shortest side S. So this is the shortest. okay, the shortest side. And so some other side is going to be 100 feet longer than that. So this is going to be 100 plus s. And the third side is going to be 200 feet longer than the shortest side, so 200 plus s. So now we want to find the lengths of all three sides. So what we can do is just set up this little equation. I don't know what the a, b, and c are. It doesn't really matter. We're just adding up the sides. So we've got s, which is the shortest side, plus the middle side, 100 plus s, plus the longest side, 200 plus s. And this is an equation we can use to solve for s, and from s we can get all the other sides. So I'll combine my like terms. S plus s plus s is going to be 3s. 100 plus 200 is 300. Then if I subtract 300 from both sides, I'm going to get 1,500. And then if I divide 1,500 by 3, I get 500. So the shortest side is 500. Looking at our answer choices, it's pretty obvious what our answer is going to be because D is the only one that has the shortest side is 500. But you can see that this would be right anyway because the two other sides are going to be, when you add 100 and 200 to 500, will give you the 600 and 700. So yeah, we've got confirmation here that D is the right answer. Another thing you could do is just kind of go through the answer choices and find out which one adds up to 1,800 and also meets these conditions. So you don't necessarily have to solve this one algebraically. Number 34 said the sum of the squares of two consecutive integers is 41. Find the integers. So if the first integer is n, then the second integer is n plus 1. So it says the sum of the squares, so n squared plus the next number, which would be n plus 1 squared, is 41. And I would just kind of go through and see, which ones work here. So let's do 4 and 5 work. Let's start with that. So does 4 squared plus 5 squared, does that equal 41? 4 squared is 16, and 5 squared is 25, and those do in fact add up to 41. So 4 and 5 definitely are going to be at least one of our solutions. It looks like it's possible there's another too. But since these second two options don't have the 4 and 5 option, we can cross those out safely. So the next thing to do is check -4, -5. And as you're typing this into your calculator, make sure that you are putting these negative numbers in parentheses because otherwise you'll get the wrong answer. But yes, in fact, if we do type this in, we'd get the same thing. We get 41. So our answer is A. You could also try to solve this equation over here, but this turns into a quadratic, and I think solving it that way is going to take a lot longer and probably lead to more errors than if you were to just check the answer choices. And I'm hoping by now, by question 34, you're starting to see a pattern here, which is that a huge chunk of these questions you don't actually have to know how to solve algebraically, you just have to know that you can plug in the answer choices and see which one works. Number 35 says the length of a rectangle is 10 inches more than its width. So here's my rectangle. We'll call this the length. It's 10 more than the width. And, well, actually, usually I guess the length down here. And here's the width. Doesn't really matter, but yeah. This looks like the longer side, so I'll make that 10 plus the width. It says if 5 inches are taken from the length and added to the width, the figure will become a square. Okay. With an area of 106 square inches. So what are the dimensions of the original figure? So if we had a square that's 196, the dimensions of that square would be the square root of 196. So the square root of 196 is 14, meaning that the side lengths here would have to be 14 and 14. Now, this would be if you took 5 inches from the length, so subtract 5 from the length and add 5 to the width. So if that's the case, then if we added 5 to the width, then the original width would have been 9, and then the original length, which is 10 more than the width, would be 19. So the dimensions of the original figure that just disappeared on me for some reason. I'll just redraw it. Will be 9 and 19. Our answer is C. Number 36 says a bag contains 9 red marbles, 2 blue marbles, and 5 green marbles. What is the probability of choosing a blue marble? So to calculate probability, we're going to divide the number of desired outcomes by the total number of outcomes. This is just how you calculate probability in general. So in this case, we want to know the probability of choosing a blue marble, and we can see that there are 2 blue marbles, so it'll be 2 over the total number of marbles, which is 9. There's nothing really to calculate here. Oh, wait a minute. A bag contains 9 red marbles. Oh, I'm sorry, I didn't read that closely enough. 9 red marbles, 2 blue, and 5 green. So the total number of marbles here is not 9. Sorry, there's just 9 reds. Would be 16. So once that's your probability, 2 out of 16, and the only thing left to do here is reduce that, which would be 1 over 8. Our answer is B. Number 37 is a very similar problem, so we'll use this I'll actually leave this up here so you can see it. This is asking for what is the probability of choosing a marble that's not blue? So the number of marbles that are not blue would be the red and the green. There's 7 red and 1 green, so that's a total of 8 not blue marbles. And the total number of marbles would be 7 and 4 is 11 plus 1 is 12. So it'd be 8 out of 12, which reduces to 2 out of 3. I divide both of those by 4. So our answer is B. Number 38 says a 6-sided die is rolled. What's the probability of rolling a number less than 6? So there are a total of 5 sides on the die, 1 through 6. And if you want to know the probability of getting less than 6, well, there's only 5 options there, 1, 2, 3, 4, and 5, out of a total of 6 options. So there's nothing, you don't even have to reduce this. The answer is D. Number 39 says a card is randomly drawn from a standard 52 card deck. You win $10 if this card is a spade or an ace. What is the probability that you will win the game? So there are 13 different cards. There's the numbers 2 through 10. Okay. There's also a jack. Or here, let me, instead of trying to handwrite this with a mouse, let me type it out. Okay, so here's the possible, what do I want to say? Suits. Or not suits, but numbers, I guess. I don't really know what you call these. But anyway, so every card is any number between 2 and 10, but it could also be a jack, a queen, or a king. So these are 13. 13. They're not suits. What are they called? Numbers. 13 different numbers. And then each number appears 4 times because you have 1 for each suit. There's a total of 4 suits. You've got spades, clubs, diamonds, and what's the other one? Hearts. So there's 4 different suits. Okay, so this says you win $10 if the card is a spade or an ace. What is the probability that you will win the game? So you got to be careful here because we're still going to use this formula, right? The number of desired outcomes out of the total number of outcomes. So what we need to do is figure out of the 52 cards, how many are either spade or aces. So there are going to be a total of 13 spades, right? There's 13 values. Oh wait, I missed one, the ace. You recognized that before I did. But yeah, so there's 13 spades. So first with 13, but then it's not just if it's a spade, it could be an ace or a spade. So since there are 4 aces in a deck, you might think we want to add 4 here, but one of them is going to be a spade, and we've already accounted for that. So there's only 3 more aces left. So this will be 16 over 52, and if we reduce 16 over 52, we get 4 out of 13. Number 40 in our last problem says a coin is tossed 3 times. What is the probability that lands on tails exactly 1 time? So to have a combined probability, we want to multiply the different events. So the probability of, oh wait, what's going on? That it lands on tails exactly 1 time. So here are the options here. Like we could have a situation where we throw the coin 3 times, it's heads all 3 times, right? Then we could have, one where we get heads twice and then a tails, or we might get one that has a heads and then a tails followed by another head, or we might get a head and then 2 more tails. And is that all as far as, yeah, I think that's all as far as getting the head first. But let's say we did not get the head first. Let's say that we got a tail first. So that the possibilities here would be getting all tails, or getting a tail followed by another tail and then a head, followed by a tail. Let's see here. We could get tail, heads, tails, or we could get tails, heads, heads. I think I got them all there. And I think that's all the different possibilities here. Look at that one more time before I make that conclusion. But yeah, this is it. So there's a total of 8 different events. And the ones that have tails exactly 1 time are going to be this case, and this case down here. So there's 3 out of these 8 possibilities, and that's going to be our probability. If you put 3 divided by 8 into the calculator, you'll see that it's 0.375, and so our answer is B. That concludes this review. Just remember that the actual test is only going to be 20 questions, so this is going to be way longer. So yeah, I guess that about wraps it up for today. This video is getting a little long, so I'm going to cut myself off here. Y'all have a great day. Thanks for watching, and I'll see you next time.